It wasn't the storms that first betrayed Jupiter. It was its gravity. As NASA's Juno spacecraft skimmed just a few thousand kilometers above the giant planet's cloud tops, radio signals returning to Earth began to shift by impossibly small amounts. The spacecraft was being pulled ever so slightly off course. Those tiny changes were enough to tell scientists that something deep inside Jupiter was not where it was supposed to be. At first, the expectation seemed perfectly reasonable. Jupiter had always been described as a planet that grew patiently. A dense, rocky core formed first. Then, gravity gathered an enormous blanket of hydrogen and helium until the largest planet in the solar system emerged. But the gravity measurements refused to fit that picture. Instead of finding most of Jupiter's heavy material packed into a compact central core, the data revealed something far stranger. The heavy elements were spread through an enormous region, reaching nearly halfway toward the planet's surface. There was no sharp boundary separating rock from gas. The center faded gradually into the surrounding layers, like muddy water dissolving into liquid metal. The familiar textbook image had survived for decades. The planet itself had quietly erased it. That left scientists with a new mystery. If Jupiter did not have the clean interior expected from peaceful formation, then something powerful must have rewritten its deepest structure. Not yesterday, not after billions of years. Very early, while the solar system itself was still under construction. The evidence was invisible to any camera, but gravity had preserved the record. Scientists reconstructed Jupiter's interior the same way investigators reconstruct an unseen accident. Every slight tug on the spacecraft pointed toward hidden concentrations of mass. Piece by piece, those measurements assembled a three-dimensional picture of a planet whose center looked less like a solid foundation and more like an enormous cloud of dissolved planetary material. Jupiter now meant something different. It was no longer simply the solar system's largest planet. It had become physical evidence. For a while, another explanation remained possible. Perhaps giant planets simply developed unusual interiors over time. Maybe heat slowly stirred heavy elements upward until the core became blurred. If that were true, Jupiter would still fit the traditional story. Only the details would need adjustment. Then the computer models began testing that idea. Again and again, ordinary formation failed. Once a growing planet reaches roughly 10 times Earth's mass, it rapidly captures surrounding gas. That process naturally leaves the heavy rocky material concentrated deep at the center. The simulations showed that convection alone could not spread so much dense material across such an enormous region and keep it there for billions of years. The observations demanded far more energy than peaceful growth could provide. Another reconstruction offered a far better match. Imagine a young Jupiter still forming inside the ancient solar nebula. Around it, other planetary embryos were also growing. One of them, roughly 10 times Earth's mass, drifted onto a collision course, not because Jupiter hunted it, but because gravity steadily reshaped unstable orbits until impact became unavoidable. The collision would have been almost impossible to witness. Its consequences remain impossible to hide. The incoming world plunged through Jupiter's immense atmosphere and struck the young planet's original core. The energy released would have shattered both structures, throwing enormous amounts of heavy rock and metal into the surrounding layers, where pressures exceeded anything found on Earth. There, hydrogen no longer behaved like an ordinary gas. Under crushing pressure, it transformed into liquid metallic hydrogen, a shimmering, conductive fluid, capable of dissolving rock and iron over immense stretches of time. Instead of preserving the destroyed world as buried fragments, Jupiter gradually blended its remains into an expanding mixture that still survives today. The diffuse core was no longer just an unexplained curiosity. It had become the scar left by a planetary collision. The planet returned once again, only this time it carried a different meaning. Its immense size no longer represented simple success in gathering gas. It represented survival after catastrophic violence during the earliest moments of planetary formation. That could have been the end of the investigation. A remarkable impact. An unusual interior. An isolated event. Except another part of the solar system refused to fit that conclusion. Mars. Compared with Earth and Venus, Mars is strangely small. Traditional models predicted far more building material should have existed where Mars formed. Yet somehow, that region ran out of the raw ingredients needed to build a larger world. The asteroid belt offered another clue. Instead of containing enough material to assemble planets, it is remarkably depleted. Individually, these puzzles seemed unrelated. Together, they pointed back toward Jupiter. Dynamic simulations suggest that while still young, Jupiter did not remain fixed in its present orbit. As it accumulated mass, interactions with the surrounding gas disk likely pulled it inward toward the Sun, before later interactions involving Saturn reversed that migration and carried both giant planets outward again. That journey dramatically altered everything nearby. As Jupiter moved through the young solar system, its gravity scattered countless smaller bodies, disrupted growing planetary embryos, and cleared away enormous amounts of material that otherwise might have built additional worlds. Mars never received enough building blocks. The asteroid belt never recovered. The same planet whose interior preserves evidence of one violent collision also appears to have reshaped the entire environment where neighboring planets were trying to grow. By now, Jupiter had changed once again. It was no longer merely a survivor. It had become one of the dominant forces that determined which worlds survived beside it. That realization reaches far beyond our own planetary system. Astronomers now know that giant planets are common around other stars. Many occupy orbits that suggest dramatic migrations and turbulent histories. Every new system raises the same possibility. The largest planet may not simply record how a planetary system formed. It may explain why that system looks the way it does. Jupiter still fills the night sky with the same familiar striped face that generations have admired through telescopes. Nothing visible hints at the violence hidden beneath its clouds. Yet deep inside, gravity preserves a dilute core stretching through much of the planet. It remains a physical record of worlds that never finished forming and of ancient collisions that changed the architecture of the solar system itself. The biggest planet did not simply emerge from creation. Modern evidence suggests it helped decide what creation would ultimately become.